Good morning, all of you. Today's our topic is of the subject of advanced surveying, and the unit name of the topic, that is the Theodolite surveying. The total weightage for this Theodolite surveying unit, that is 24 marks. In this unit, the MSBT asks for the exam 2-mark question, 4-mark question, and 6-mark questions. So in this Theodolite surveying unit, we learn how to prepare plan using Theodolite surveying. That is the course outcome of our unit number 2. That is prepare plan using Theodolite survey. In unit number 1, we have to study how to prepare plan using plane table survey. So the accuracy of this plane table survey is less as area of the survey is increases. So to advantages due to these advantages of plane table survey, the next equipment becomes for survey, that is the theodolite. Now in this theodolite surveying, the practical outcomes, that means how many practicals are we have to perform on this theodolite surveying. First, that is use of transit theodolite to measure the horizontal angle correctly by direct method. This is the number one practical. Second one, use transit theodolite to measure vertical angle correctly by direct method. Second one, use transit theodolite to measure horizontal angle correctly by repetition method. And next one, use transit theodolite to carry out the survey project for close traverse survey for minimum 5 site traverse. So these are the practicals performed with the help of instrument, that is theodolite instrument. Now the unit outcomes of these theodolite surveys are, say, explain the given components of the transit theodolite. That means the theodolite is an instrument. In that theodolite there are many different components of that transit theodolite. So the component of transit theodolite are explain their function. Next one, describe the salient features and relationship between the given fundamental axis of the theodolite. So these are the second outcomes of our unit outcomes. So there are four essential fundamental axis of the theodolites. So there is a relationship between fundamental axis of theodolites. So what is the relationship between these fundamental axes we see in this unit? Next one, describe the procedure to measure horizontal angle and vertical angle by using theodolite for the given situation. That means in previous lectures or in previous topic, we only measured the horizontal angle with the help of prismatic compass, or in plane table survey we not measure horizontal angle. So in prismatic compass the limitation is only for measurement of horizontal angles. If we require to measure the vertical angle, the instrument is becomes, that is the theodolite. So with the help of this theodolite, how to measure vertical angle and horizontal angle we learn in this unit. Next one, apply check for determining the type of traverse using given data. So we when we perform any surveys with the help of theodolite traversing, there are some kind of errors occur in the theodolite surveying. So eliminating of these errors are you with the help of checks for determining the type of traverse. As we know, there are mainly two types of traverse. First one, open traverse and closed traverse. So when the survey traverse survey is done with the help of theodolite, there are two checks, one for open traverse and second for closed traverse are applied for the correction of the traverse. Next one, I compute latitude, departure, a consecutive coordinate, independent coordinate from given data. as we know in plane table survey, we plot the traverse when measurements are done simultaneously on the ground. But in case of theodolite surveying, first we take the measurement on the site or field or on ground, and then after the plotting procedure is done in the laboratory. So there is a necessity of calculating the coordinate coordinate of traverse. Such coordinate is called as latitude coordinate, departure coordinate, consecutive coordinate, and independent coordinate from the given data. The given data is nothing but the horizontal angle of the traverse and length of the traverse. From this measurement data on the field, we calculate the coordinate of traverse, and with the help of this coordinate we plot the traverse on the sheet, and in that traverse we can locate our details. So next one, unit outcomes are select relevant method of theodolite traversing for given conditions. So when we study this unit number 2 of theodolite traversing, we are able to choose the method of theodolite traversing for given conditions. Next one, apply Bowditch rule and transit rule to balance the traverse for given data. As stated earlier, there are some kinds of error in theodolite traversing. So, for removing of these errors, some rules are used. First one, Bowditch rule, and second one is transit rule. So, when we study the unit number 2, we understand what is the Bowditch rule and transit rule for balancing the traverse for given data. That means when we take the measurement on field, there are some kind of errors occur in the measurement. So these errors are eliminated with the help of Bowditch rule and transit rule. This procedure is called as a balancing the traverse. And last one, unit outcomes to understand the Gale's traverse table. When we study the unit number 2 theodolite traversing, we are able to understand the Gale traverse table of the given traverse. That means when we plot the traverse on sheet, this traverse is plot with the help of coordinated of this traverse. So the field data and calculated data are present in a one tabular form. This tables is Gale traverse table. When we study the unit number 2, we understand what is meant by Gale's traverse table. So these are the our outcomes of the units. So actually we start our unit number 2, that is the theodolite traversing. So the weightage of this theodolite traversing unit is a 24 marks as per MSBT norms. In this topic, the question asks for MSBT exam on 2 mark question, 4 mark question, and 6 mark questions. So in 2 mark question, some definition and some component part of the theodolite and their function are used. In 4 mark question, the procedure for measurement of horizontal angle as well as vertical angle, this procedure is asked for 4 mark question. And in case of 6 mark question, there are some problems of calculating the coordinate of traverse and balancing of traverse. On these two topics, 6 mark questions, that is problematic question, is asked on MSBT or in MSBT exam. So now we start our unit number 2, that is theodolite traversing. So what is meant by theodolite traversing? Theodolite, what is meant by exact theodolite? The theodolite is an intricate instrument used mainly for accurate measurement of horizontal and vertical angle up to 10 second to 20 second depending on the least count of the instrument. Because of its various uses, the theodolite is sometimes known as universal instrument. As we know in previous unit number 1 plane table survey, we prepare the plan using plane table survey. So there are some disadvantages of plane table survey. Due to these advantages, the we cannot measure vertical angle with the help of plane table, so or horizontal angle with the plane table. As we required more accuracy, we becomes come toward the theodolite. The theodolite is nothing but an artificial instrument, is used for measurement of horizontal and vertical angle up to 10 to 20 seconds. So the angles measured in the unit degree, minute and second on the field. So this theodolite instrument is having least count of 10 second to 20 second. As the accuracy of this instrument is increased, the least count of the theodolite is also increased. 10-second theodolite means the least count of this 10 theodolite is a 10 second, and 20-second theodolite means the least count of this theodolite is a 20 second. So theodolite has very uses in our field condition. Hence, this theodolite is also sometimes called as a universal instrument. So various uses such as a measurement of horizontal angle, measurement of vertical angle, next one measurement of bearing of the survey line, next one uh, prolonging a straight line, uh, next one setting up of curves. So these are the many uses of the theodolites. Due to these various uses, the theodolite is called as universal instrument. So what are the next topic is what are the uses of the theodolite? First one is use measurement of horizontal angle. The first use and important use of theodolite, that is measurement of horizontal angle. As we study prismatic compass survey, in prismatic compass survey we measure bearing, fore bearing and back bearing, that is magnetic bearing of line. With the help of prismatic compass we cannot measure or we cannot find out the direct angle between 2 points. So due to these disadvantages, and one disadvantage of prismatic compass is the least count of the prismatic compass is only 30 minutes. So in theodolite the least count of this theodolite is a 10 second, and some theodolite having least count of 20 second. So first one use, when we require to measure the horizontal angle between 2 points, we can directly measure with the help of theodolite horizontal angle between that 2 points. We does not require to measure the magnetic bearing of these 2 points for calculating the horizontal angles. As we know, there are some limitation of prismatic compass such as a magnetic declination and local attraction. Such type of errors are not occur in this theodolite surveying. Next one, measurement of vertical angle. As well horizontal angle as well as vertical angle we can measure easily with the help of theodolite. So horizontal angle is measured in the horizontal plane when in the ground two station point are set and we require the angle between these 2 points. We can easily find out the angle between these 2 points with the help of theodolite. Next one, the vertical angle is measured in the vertical plane as we required vertical angle for calculating the height of the building. So this theodolite is very useful. Next one, measurement of magnetic bearing of line. As we know, the magnetic bearing of line is measured with the help of prismatic compass, but the least count of this prismatic compass is only 30 minutes. So accuracy of survey is our survey work is increased. So the accuracy of measurement is also increased. So due to these advantages, the magnetic bearing of lines we can measure up to 20 second or 10 second least count. Next one, measurement of deflection angle. So for setting out the alignment of a railway track, alignment of roads, alignment of canal, we require to measure the deflection angle of that alignment. So with the help of theodolite we can easily measure the deflection angle between the 2 points. Deflection angle is nothing but angle between preceding line and proceeding line. Next one, use measurement of horizontal distance between 2 points. Next one, use of theodolite is a measurement of measuring the horizontal distance between 2 points. With the help of theodolite, we can easily measure the horizontal distance between 2 points. With the help of vertical angle and staff reading at that point, we can easily find out the horizontal distance between instrumentation and staff station. These uses become useful in undulating ground. So with the help of tape, we cannot measure the distance in undulating ground. So with the help of theodolite, we can easily calculate the horizontal distance between the 2 points. Next one, find the vertical height of an object. The sixth uses of the theodolite. With the help of vertical angle and the length between instrumentation and building, we can easily find the height of the building. So that is the one important use of the theodolite, that is the finding the vertical height of an object. Next one uses of theodolite are finding the difference of elevation between various points. That means with the help of Dempsey level or Atto level, we can find the elevation difference between various points, as well as with the help of theodolite we can find the elevation between various points on the ground, as well as the vertical angle and horizontal angle between 2 points simultaneously can be measured with the help of theodolite. Next one, ranging a line. That means when we fix starting 2 points and in that straight line we can fix many points on that straight line with the help of theodolite. This procedure is known as a ranging a line. So these are the 8 uses of the theodolite. There are many uses of the theodolite, hence this theodolite is called as the universal instrument. Next topic is, that is the types of theodolite. So based on type of telescope, the theodolite is classified as transit theodolite and non-transit theodolite. So there are mainly two types of theodolite, transit theodolite and non-transit theodolite. So we first seen transit theodolite. So transit theodolite means the theodolite whose telescope can be rotated in the vertical plane. This theodolite is called as transit theodolite. Transit theodolite, that is means the theodolite whose telescope can be rotated in the vertical plane. That means with the help of that theodolite we can easily measure the vertical angle. This theodolite is called as a transit theodolite. That means this theodolite having a vertical circle, and that with the help of that vertical circle we can measure the vertical angles. Second type of theodolite is non-transit theodolite. So non-transit theodolite is a vice versa of transit theodolite or opposite of transit theodolite. Non-transit theodolite, that means the theodolite whose telescope cannot be rotated in the vertical planes. So this theodolite is called as a non-transit theodolite. That means with the help of non-transit theodolite we cannot measure the vertical angle. We only measure the horizontal angles. So these are mainly two types of theodolite based on the type of telescope. Type of telescope is nothing but that is the moment of, depending upon the moment of telescope. In transit theodolite, the telescope can be moved in horizontal plane as well as vertical plane. But in case of non-transit theodolite, the telescope of this non-transit theodolite can be only rotate in horizontal plane but cannot rotate in the vertical plane. Now move toward the second classification of theodolite, that is based on the reading unit. Based on reading unit. So theodolite is classified based on reading unit in three groups. First one, vernier theodolite. Second one, micrometer theodolite. And last one, digital or electronic theodolite. So we first see what is meant by vernier theodolite. Based on reading unit, that means on which unit we take the reading of horizontal angle and vertical angle. That means on which system in this vernier theodolite for taking the reading, two verniers are provided for taking the observation of horizontal angle and vertical angle. So this theodolite is called as a vernier theodolite. If this vernier theodolite is a transit theodolite, that means it's called as a vernier transit theodolite. If the theodolite is a non-transit, that means this theodolite is called as a non-transit vernier theodolite. So in vernier theodolite, for taking the observation for horizontal reading, for horizontal observation, two verniers are provided, and with the help of these verniers, we take the observation. And also for vertical observation or vertical readings, vertical circle reading, two verniers are provided, and with the help of these two verniers we take the vernier reading. Hence, due to provision of vernier for taking the reading, this theodolite is called as a vernier theodolite. Next one, that is the micrometer theodolite. So micrometer theodolite is nothing but for taking the observation of horizontal angle and vertical angle, the micrometer system is provided, and with the help of this micrometer system we can measure the horizontal angle and vertical angle as very accurate. So next one, classification, that is the digital theodolite and electronic theodolite. So in these first two classification, the physical taking of physical reading is essential, but in case of digital theodolite we only need to bisect the object. The reading of this horizontal angle and vertical angle is automatically display of the theodolite. So there is no need of taking the observation of micrometer reading and vernier reading. The reading is automatically will be automatically display on the display of digital theodolite. So the accuracy of this digital theodolite is more accurate as compared to this vernier theodolite and micrometer theodolite. So vernier theodolite has a less accurate, micrometer theodolite has greater accuracy as compared to vernier theodolite, and digital theodolite is having great accuracy as compared to vernier theodolite and micrometer theodolite. So these are the image of these three classification of theodolite. So this is the vernier theodolite. That means so these are the vernier theodolite. That means there is a provision of these verniers, vernier for horizontal circle and vernier for vertical circle, taking the observation. And this theodolite is called as a vernier theodolite. Next one, this micro-optic theodolite. This is the second one image of micro-optic theodolite. So in this theodolite, such verniers are not provided for taking the observation. With the help of micro-optic system, we can observe the horizontal angle and vertical angle of the theodolite. And third one is the digital theodolite or electronic theodolite. So there is a provision of display for taking the observation of horizontal angle and vertical angle of the theodolite. So these are the three classification of the theodolite based on the reading unit. Next topic is the component parts of the theodolite. So next topic is the component of component part of transit theodolites. So on this topic 2 mark questions are asked for the examinations. That means the some component parts are state for examination and their functions of these component parts are asked for examination. So there is a cross-sectional view of theodolite, transit theodolite, and on right side of the image the component part of this transit theodolite are marked. So first one part component part of transit theodolite is telescope. This part is called as a telescope of transit theodolite. The function of this telescope is to bisecting the object to bisecting the object for measurement of horizontal angle and vertical angle. So this is a longitudinal part of the theodolite is called as a telescope. This telescope having two veins for bisecting the object. One vein is a eyepiece. This vein is called as eyepiece and this vein is called as a object vein. So with the help of eyepiece and object vein we can easily bisect the object. Next one component part is a altitude bubble. Next one component part is a altitude bubble. So there is a provision of altitude bubble. The use of altitude bubble is to make the vertical axis of theodolite truly vertical. So this is the vertical axis of the theodolite. So this is the vertical axis of the theodolite. When we set the instrument on the tripod stand, this instrument is not accurately level. With the help of this foot screw, with the help of this foot screw, we with the help of this foot screw, we make the leveling of the theodolite. So when leveling is perfectly done, the position of water bubble, this altitude bubble, comes in the exact center of this altitude bubble tube. So the function of this altitude bubble tube to make the vertical axis of theodolite truly vertical. Next one component part is a vertical clamping screw. Vertical clamping screw. This screw is called as a vertical clamping screw. So function of this vertical clamping screw is to stop the motion of this theodolite in the vertical plane. Stop the motion of this uh, telescope in the vertical plane. When this vertical clamping screw is clamped, the motion of the telescope is prevented or stopped. Next one component part is a Trunnion axis. This dotted line as shown in figure, this axis is known as a Trunnion axis. Trunnion axis in the thing but is also called as a horizontal axis. So the Trunnion axis is nothing but the axis about which this telescope is rotated in the vertical plane. This axis is called as a Trunnion axis. So about this horizontal axis, the telescope is rotated in vertical plane. This axis is called as a Trunnion axis. This Trunnion axis is mutually perpendicular to the vertical axis. Vertical axis is nothing but the axis, this is the vertical axis, the axis about which the theodolite is rotated in horizontal plane. This axis is called as a horizontal axis. So these two axes, fundamental axis, first one Trunnion or horizontal axis and second one is a vertical axis. These two axes are mutually perpendicular. Next one, that is the component part vertical circle. So this part of theodolite, is called as the vertical circle. So main function of vertical circle to measure vertical angle. With the help of vertical circle, we easily measure the vertical angle up to accuracy of 10 seconds or 20 seconds. Second one is a eyepiece. This part of theodolite is called as a eyepiece. This is a part of telescope. Eyepiece is used for focusing the object. When we bisect any object, the image of this object, the image of this object and diaphragm is provided in this eyepiece, the clear with the help of eyepiece. There is a provision of uh, rotating screw in the eyepiece. When we move this rotating screw in clockwise direction as well as anti-clockwise direction, the image of crosshair or diaphragm become sharp and clear. Next one instrument is a next one component part is a plate level. This level is called as a plate level. So what is the use of plate level? When we set the instrument on tripod stand, this instrument is not exactly level. So there is a first aim of Theodolite to make there is a first aim of our is to make the instrument exactly truly vertical and horizontally level. So when we set the instrument exactly level, the water bubble of this plate level tube, it is also called as the horizontal level tube, is become or longitudinal level tube is become exactly center of this level tube. This procedure is done with the help of this 3-foot screw of the Theodolite. Next one is a next component part is a upper plate part. Upper plate part. So upper plate part means this is the upper plate of horizontal circle of Theodolite. So there two plates are provided for two circles, upper plate and lower plate for horizontal circle and upper plate and lower plate for vertical circle. So on upper plate the graduations are marked in minute and second, and in lower plate the graduations are marked in degree and minute. When we measure any angle on theodolite, we take the reading on upper plate in minute and second and lower plate reading on lower plate degree and minute. The combination of these two reading we get the final angle. Next one is a vernier A and B. Next component part is a vernier A and vernier B. So this use of vernier A and B is to measure the or to take the reading which occupies in upper and lower plate. So with the help of this vernier A and B, we easily take the reading of horizontal circle. Next one, inner spindle. Next component part is a inner spindle. Second component part is a outer spindle. Now this part is called as a tri-brach plate. Tri-brach plate. So tri-brach plate is the nothing but tri-brach plate is nothing but this plate are mounted on the trivet plate and foot screw. This tri-brach plate is supported on this trivet plate and foot screw. Next one component part is a leveling screw. This part is a leveling screw. So this screw, leveling screw, this is also called as a foot screw. Leveling screw is also called as foot screw. The 3-foot screw or sometimes 4-foot screw are provided for the leveling purpose to the theodolite. So with the help of this foot screw, we make the theodolite exactly horizontal and the vertical axis of truly make vertical. And next component part is the main function of this leveling foot screw is what is the leveling purpose. This leveling foot screw is used in theodolite traversing for leveling purpose. And last one part is called as a trivet part. See this trivet part is used for fixing the base of theodolite on the tripod stand. So the combination of this part, first one tri-brach part, second one leveling foot screw, and third one is a trivet part. This part combination of these three part is called as a leveling head. So what is meant by leveling head? Combination of tri-brach plate, leveling foot screw, and trivet plate. This head is called as a leveling head. So these are the component parts of transit theodolite. On this topic, some component parts are stated in examinations and we are asked to write the function of this component parts. Sometimes what is the function of telescope? What is the function of altitude bubble tube? What is the function of leveling foot screw? Such type of 2 mark questions are asked on this topic. So there is a enlarged image of telescope. There is a enlarged image of telescope. As we seen is the first part telescope. So there is an enlarged image of this telescope. So telescope consists two vane, I vane and object vane. So this is a altitude bubble tube. So this is the vertical clamping screw and this is a tronian axis. This vertical axis is called as a tronian axis and horizontal axis is called as a tronian axis and this is a vertical axis. So these are the enlarged image of theodolite. So next part is continuing in our next video. That is part is reading the vernier of transit theodolite. How to read the vernier of transit theodolite.